The second method here is mean squared error, so MSE. And what this does is you take the summation of each error for the current period or for each period, square it, and then divide it by the number of periods. So this is an example. So you have 155 minus 130, you get 25. You square 25, you get 625. And then you take the average of these 5 values to arrive to 219. So that's your MSE. So intuitively, what this means is that if you miss something, then you miss big here, because terms with bigger errors, they are penalized more, right, due to the square term. So you get to 1 here. And then the last technique here is the MAPE. So what this does is technically you do a normalization. So you have ET, the error term, for each period. You divide by the actual demand for that period. Take the modulus, sum it over T, and divide it by T. Here you will see that this resembles the coefficient of variation. So the way the normalization works in the coefficient of variation, where you have the standard deviation divided by the mean, this is similar here. So let's work through this example here. And in period 2, we have 155 minus 130, we get 25. 25 divided by 155, this is my AT. And so I get 16.13%. I want to take the absolute given the modulus sign here, so that's 16.13. Right, and then in period 3, you can see the difference is that I get minus 6.9, but due to the modulus sign, I get 6.9. Take the average over these three values plus the last two, so 5 values, you get 8.79%. So this will give you in percentage form. So comparing the 3 different methods, the similarity of these methods are that the errors with opposite signs, they do not cancel out each other when they are added, so that's great. The differences, MSE places higher penalty on large errors due to the squared terms, whereas MAPE allows comparison between the different demand processes with different means due to the normalization effect, as we saw in the lecture about the coefficient of variation. Whereas MAE and MSE, they're only good for comparing different forecast methods for the same demand process. Now, I'm going to give you a quick note on expert panels and subjective forecasting to complement the materials that we've gone through so far about objective forecasting. This slide is non-examinable, and we're going to talk about 3 methods of subjective forecasting, and they all involve people, they all involve human beings. So the first method is forecast combination among several forecasters. So this entails combining forecasts that are generated by different forecasters into one single value. So this is akin to taking an average across different values. The second is forecast with consensus building. This is an iterative discussion among experts about their forecast and opinion that leads to a single forecast. So unlike the first approach that simply take the values for granted, in the second approach, you're going to ask each of the forecaster about how they derive their estimates so that you understand the rationale and can make the necessary adjustments to the estimates if necessary. The third method here is prediction markets. So this is akin to a betting game in which forecasters can place financial bets on their forecasts. So take for example betting odds published by Horse Track. Now with all these different methods, because they are associated with human beings, naturally there will be biases built into these forecast estimates. And we're going to talk about 3 sources of forecasting biases. The first is overconfidence. So this captures the fact that human decision makers are overly confident in their ability to shape a positive outcome. The second is anchoring, so using a piece of information as a reference point, and this captures bias associated with the fact that human decision makers are selective in their acquisition of new information, looking only for what confirms their initially held beliefs. The third is incentive alignment. This is very common in the industry. Take, for example, a salesperson who is paid a commission on sales. So naturally, he or she will align the forecast estimates that may be more favorable for him or her in terms of the incentive that he or she is getting from the estimates that he or she produces. I want to show you a short clip that I think aptly captures these sort of issues in the industry.
Hi Jane. I'd like to review your sales forecast with you.
Sure, Bob.
It looks like you have $2 million in revenue forecast for this year. I'd like to make that $3 million.
But I think I am going to sell $2 million worth of products this year. That is why I made $2 million my forecast.
Yes, but I would like to make $3 million your stretch forecast.
A stretch forecast? Okay. But will you actually expect me to bring in $3 million if that becomes my stretch forecast?
Of course, Jane. That is why we call it a forecast.
So I want to introduce to you a framework for implementing a forecasting in practice. This is a 5-step procedure. In the first step, you will collect data, including all demand forecasts. They can be both objective or subjective data, as well as the actual demand outcomes. So these will form the set of historical records that you have. And once you have that, you can proceed to the second step, and that is to establish the forecasting method. Decide on the balance between subjective and objective data and look for trends, right? So in this course, for this lecture, we talk about trends. We have omitted seasonality, but this is also another important aspect that typical forecasting model will attempt to capture. So think about, say, in December every year, we know that festive season is going to generate peaks in demand. So this has been omitted from this lecture. If you're interested to find out more about seasonality and how to capture that in a forecasting model, please refer to the bottom of this slide. So with that, we can move on to step 3, and that is to forecast future demand using a forecasting method. These are the various models that we have considered in this lecture. Typical approaches will implement at least 2 or more of these different models, and then find out which one of the model will give you the best estimates. And we typically use the naive model to generate the first period, so looking at past demand. Then we move on to step 4, which is to make decisions based on step 3. And if you want to kind of evaluate the model performance, we can proceed to step 5, and that is to measure the forecast error, looking for biases and attempting to improve the process. And we introduced to you 3 different metrics for evaluating the forecast error. The MAE or MAD, they are the same. MSE and MAPE. Alright, so once you complete step 5, there is a possibility that you may need to revisit one or many of these steps so that you can revise the estimates that are generated in each of these steps. Alright, so obviously forecasting can be hard. This is an extremely hard process, and you get paid a lot if you can do a very good job there. And so I want to leave you with some quotes for you to read at your own pleasure. These are very interesting, and the source of these quotes come from this link. And so with that, I thank you so much for watching this video. Have a good one.